equals 2. What would be the shape of the distribution of sample means?
Skewed right.
Skewed.
Yep.
Because it's not big enough to make it normal.
Hey, just so you guys know, I just started recording the meeting because Kayla said she's not going to be able to make it and asked that we record it.
Okay. Yeah, because this wasn't required to record it, was it?
Correct, yeah.
Well,
so I'm just going to I'll record it and email her the link.
Okay, cool.
Okay. So tanker trucks carry fuel, capacity of 8,550 gallons. Actual capacity is normal distributed with a mu of 8554 and a standard deviation of 12. So 8. Suppose a simple random sample of N 20 tanks is selected and the sample mean capacity is found to be 8,550 gallons. What is the z-score corresponding to the sample mean? You want to know what's funny? Have you guys seen the question in the book?
I won't lie to you.
No.
I have not.
Where the heck did it go? There is a major typo because it says right out of it, it says corresponding to a sample mean capacity for 20 tanks of 8544. The same number as the mean. So the little sample question, the mean would have been the z-score would have been 0.
Yep.
Because it's the same as the mean. So
yeah,
that's stupid. Now I got to redo the question.
Did you guys get the z-score as a 0.5?
Hold on.
I got 2.236. Did you make sure that you divided the standard deviation by the square root of n?
Yeah, you got to divide by square root of 20.
Oh, no, I did not do that part.
Okay. But I'm doing this with a little phone calculator, so my numbers could be off.
So the formula for the z-score is the score that we're given minus the mean.
X minus x bar over standard deviation divided by the square root of n.
Okay, I need to go look at my other part of my notes then, because I have it as just over the standard deviation.
That's if it's
they don't
population.
give us a number.
That's a population.
Yeah, if they don't give us a sample size.
Yeah.
Oh.
That's population z-score, not sample.
Gotcha.
All right, did you get 2.236 when you redid it?
No.
I did.
I was too busy talking. My finger doesn't work when I talk. 2.23607.
Yeah.
Say probability that the sample mean of 50 randomly selected tanks will be greater than 8,540 gallons. So same formula. And then you have to convert that to the z-score and then get the probability, which I got 0.991.
Oh, shoot. I did 8540 minus 8550. So that's why I got something different. Give me 1 second. It's 8544 by 12 divided by square root of 50. I get a 2.35. Plug that in.
Well, I need to go. I'll be right back. I need to grab a different calculator. I'm trying to do it on my phone, and that's not working for me.
Yeah, I'm gonna go too because I'm gonna get me something to eat. I'll be right back.
I'll be right back.
Dang, I haven't eaten either. Everyone just left me. I'm all alone. There's no one here beside me.
Beside you.
Best describes the notion of the significance level of a hypothesis test.
So what did you get? What did you end up with a 0.991?
Yeah.
Eat. Goodness. So are we on to number 10? Are we still, is Jared back?
Yeah, I just got here. Sorry.
Okay.
I realized I don't have my camera's not on, so my apologies.
We'll let you slide.
You're too good to me. All right. Which of the following best describes the notion of the significance level of a hypothesis test?
The probability of a type 1 error.
Yes.
All right. The heights of young adult females in the United States are said to have a population standard deviation of 2.6 inches. The sample was taken of 85 young adult females at UIUI, and the mean was computed to be 65.4 inches. Which of the following explanations describes the correct way to interpret the 95% confidence interval for this problem?
The last one is definitely in there.
Well, it's C is kind of has the language that is, you know, it's 95% of all 95% confidence intervals that could be computed from the population of all adult females in the United States will contain the true mean height.
Right. And I think the last one's also saying that same thing, just in a different way, because we are 95% confident that the true mean height of adult females in the United States is somewhere in our confidence interval.
Yeah.
It's basically saying the same thing in two different ways, and we can have more than one answer.
Mm-hmm.
Yeah. I guess let's go with the last one then.
The third and the last one?
Yeah.
Because it's not the first two.
Nope.
And it's not that second to last one either, because
it says
anytime you just the time it says chance, you don't want any part of that.
Right.
Nobody got time for that.
Okay.
All right. Marine biologists. They're studying 16 beluga whales, and they create a 95% confidence interval. Siri, what are you doing?
Thank you, dear.
95% confidence interval to estimate the true mean weight of beluga whales. It's a normal distribution, and the standard deviation is 125 kilograms. Are the requirements?
Bye. I love you.
Are the requirements for the confidence interval met? Yes.
Yes, because the distribution is normal. Because the data are normal, right?
Oh, it's 6:20.
Yep.
Well, I'm not coming back in here.
Okay, bye.
I'm taking Colin with me because we're going to go to home.
Huh?
I'm taking Colin with me because I'm going to go Home Depot and buy wood so I can make myself a fireplace mantle.
Seriously?
You said no, and Greg said no, and Lindsay Williams told me no. So yes, she won't let me use hers.
Oh, for the party? Oh, okay.
You told me no, Greg told me no, and Lindsay told me no.
Okay.
And hers is already made. She just won't let me use it.
She's selfish. Sorry, guys.
It's all right.
I forgot to turn off my mic.
All right, my turn to let you slide now.
Okay. Yeah. Okay, so what were we determining on 12?
The second one.
Huh?
Because the
problem
data is
normal.
is
right, but it's the sample data follows the normal distribution. That doesn't mean that the population does.
No, but the population is big enough that it would end up being normal if they took samples out of every single beluga whale. Because the sample is so large, or the population is so large, it would end up being a normal sample.
Hmm.
Huh? The sample's only 16, no.
But since it's normal, it follows the requirements for a confidence interval. If the data was right or left skewed, then no, we wouldn't be able to do it because the sample size is too small. But because it's normal, we do have, or the requirements are met for a confidence interval.
I don't know. I think this is kind of one of those trick questions because it says their data doesn't say anything about the population follows the normal distribution.
Well, generally a population will follow the normal distribution just because that's why the central limit theorem exists.
No, but the central limit theorem means that your sample is going to be normally follow a normal distribution if it's large enough, right?
Yeah, and so the only reason that would happen is because, well, the central limit theorem doesn't say that about populations.
I know that's a large number.
The central limit theorem just says that if you take a large enough sample, it will be normal. That's just because tend to have a normal distribution. So, like the law of large numbers says that the bigger a sample you have, the more it tends to follow the distribution of the population. And the central limit theorem says that the bigger sample you have, the more normally distributed it will be.
Well, yeah, CLT is that, but the law of large numbers is that it's closer to the mean.
Yeah.
Your test statistic, but I'm just trying to play devil's advocate here because these word problems are my nemesis.
Yeah, I understand. They're where I screw up. I get like all the math ones right, and then screw these. But
so we're going because the data is normal.
Yes,
I agree.
And the wording on it is like, the distribution of sample means is normal because the data are normal.
Okay, 13.
And if we're wrong, I'll never question you again.
Get it? Because he's not going to talk to you again.
That's because this is the very last one we're going to do. So
listen, I don't know what you're talking about.
All right, 13. We need to pull up the rates of return Excel sheet. It looks like it's a one sample test. One sample t-test, sorry.
Yeah, and this is we've done this one before, so.
Oh, I don't remember it, but yes.
All these have been feeling pretty familiar.
Yep. So what's this asking for first? The p-value. I'm almost guaranteed that it's 0 because the t value or the test statistic is negative 11.561. That's calling out 0 to me.
Yeah, if I remember right, this one was pretty huge because the evidence was against the portfolio of actually performing. So.
Oh, wait a second. Okay, just kidding. Oh yeah, p-value is 2.6 times 10 to the negative 14th. That's 0.
I didn't read through the question. Is it it's a less than?
Yeah. So it's saying the arbitration panel compared a period in order to determine whether there was a substantial decrease. Wait a second.
I don't know what happened, but as soon as you started explaining to me, my thing froze and I caught nothing from you until just now.
Okay. It says conduct a hypothesis test to determine if the investor's portfolio performed significantly worse than the performance of the S&P 500. So it would be a less than.
All right.
And our null is 0.95. So our p-value is 0.019.
Oh, see, my null hypothesis was 10. That changes a lot.
That does change it.
0.019.
That's where I'm at.
My bad, guys. Sorry.
We will never believe you again.
That's all right.
There's a
You
lot
don't
of
have
trust
to
being
after
lost in the
today.
meeting tonight.
It's all destroyed on the last meeting.
That's all right.
A financial economist is studying married couples in which both spouses work. He wants to compare the mean income earned by husbands with the mean income earned by their wives. Should he use independent sampling or dependent sampling, and why?
Dependent.
And it should be dependent because they're comparing the husbands and wives.
Right.
So
Number 2.
Yes.
it's number 2. Yep.
Yeah, because their income doesn't depend on each other, but if you choose one, you have to choose the other.
Right.
All right. Here's the next one is what we need our other spreadsheet
Direct
for that we're given.
I have like
Yep.
4 sheets. Look.
Where is that file at? Is that at the very beginning?
Yeah.
It's at the beginning, but it's also at the bottom of the question. It's like in the second to last line.
Oh, there it is. It just wasn't
this one's
popping
hidden.
out on me.
No,
All right, so
no, don't quit. Okay.
This is one where we're comparing the 14 days versus the 90 days. So this is a paired sample.
Right.
I'm thinking it's a paired sample
The
because one is
difference.
dependent on the other.
Sounds good. Yep. That's the other part that like I have to do better about when I'm studying for this is like always making sure I'm correct about which spreadsheet to use.
Well, I'm voting that we should be able to take a group final. Who's in?
There you go.
No, Sean won't trust me, so
So we're doing the 90 day first. Is our first data, correct?
As variable 1. That's what I'm doing.
Variable 1.
Ow.
that's what I'm doing now.
Copy.
Oh man. I keep touching
That's not
something
what
and it pulls me up to the top of the page, or it tries to exit me out of the screen. My computer is just saying, how can you fail in so many different ways right now? Oh, is that? Nope. I'm looking at real estate. That's the wrong question. There we go. So it's a not equal to test.
Yep.
Null hypothesis would be 0. P-value is what they're asking for, 0.096.
That's what I got.
Which is less than the p-value, or than the significant level of significance of 0.0. It's greater.
Greater.
I'm going to stop talking.
It's greater than. So that
Well,
means that
it
we
is-
failed to reject. Right?
So it's the first
Yeah,
one.
I'm sorry. Sorry, I was just rereading the question just to make sure we had the right hypothesis test.
It's okay. My
So, yeah,
book's got all
0.0
confused or something. I don't know.
0.096 then. 0.096.
What a weenie.
Oh, we have to get a little snippet in on Kayla since she's just going to be watching this. We know why she didn't want to do this because she said she was going to have video on the last one. That's why.
That is true. That's exactly what happened.
That's why. We're calling her out on that one. Like it matters. But. Okay, so not rejecting. So it would be
Yes.
no. So that's the first choice.
Yes.
Define peace.
I'm not sure what you said.
Okay. So now the real estate company who selects random sample of 10 homes in different neighborhoods around the city and independently asks each appraiser for an estimate of the home value after they receive the estimates. The company subtracts the value given by the first one from the second one. They create a QQ plot of the differences and see that the points of the plot roughly form a straight line. Are the requirements for the desired confidence interval satisfied? Explain.
I'm thinking the third one.
Yeah, because we've done the QQ plot
Yeah.
to determine it.
And then for this one, or for the 18, sorry, I'm thinking the first one because they want them to equal each other. They don't want them to be equal to 0.
Correct.
Boom.
So that would be the first one.
Yes. All right, suppose you would create a 95% confidence interval for a mean and get negative 2.346,775. You've been told to report this by saying we are 95% confident that the true mean is between those two values. Exactly what does this mean?
Number 2. 95% of all 95% confidence intervals actually contain the true mean.
Right. Hey, on 18, we were going with selection number 1, right?
Yes.
Yes.
Yeah, that's what I thought. Okay. Sorry, because my wife walked in. The cats got operated on today, so she brought one of the cone heads in. So.
Oh, awesome.
Sorry about your cat. Funny about the cone head. Sorry, we should have been a little more.
No, it's fine. Actually, cats are nature's speed bumps. So, question 20. If P equals 4/5, what is the smallest value of N that satisfies the requirements for a normally distributed? Oh.
Because it needs to be at least 30, right?
10.
10.
You have to do the n minus blah blah,
Yeah.
the proportions, and then 1 minus the proportion.
Yeah, so it's like it's n
I got
minus
50.
it's n times p equals 10, and then n times 1 minus p equals 10.
Yeah, so 50 times 0.2 equals 10. And 50
Okay.
times 0.8 equals 40.
That's it then.
Okay. Your little brother has a career batting average of 233. You want to determine the probability that he will have an average of over 250 next season when he will be up at bat 40 times. Are the conditions met so that the sample proportion p hat will be approximately normal? Yes. I'm thinking the first one.
Yeah, because 50 times or 40 times 0.25 is exactly 10. So
So is it the second one?
it's the second one.
Oh, I was thinking not the central limit theorem.
That's central limit theorem.
Central limit theorem. Yeah, central limit theorem. I still get central limit theorem and law of large numbers mixed up. It's probably not good going into the test.
let's not let the teacher see this video. She just takes off a letter grade for that.
Yeah. And watching our video, Sean, she would reject the notion of having a group exam.
Yeah.
Oh yeah, this was recorded. Dang it.
Hey, I'm not posting it to any sort of message board. I'm just going to email the link to
Okay.
Kayla. Yeah.
Okay, we're good.
All right.
So, a geneticist.
Oh, go ahead.
Go ahead. I said
Do you want me to read it? A geneticist takes a simple random sample of n equals 140 gamete cells from the testes of a dog to determine the proportion which contained the chromosomes for development into a male. Assume the unknown true proportion of dog gametes that contain the male chromosome is 46%. The geneticist conducts her survey and calculates p-hat equals 0.512. Which of the following is the most correct interpretation of this statistic?
Third one.
It's on here.
It's what? This third one,
Sorry.
not the fourth one?
Fourth one. Sorry, fourth
Yeah,
one.
that's had to be the fourth one on that one.
Yeah. Because it's just for the sample, not for that specific dog, right?
Yeah.
Yeah.
Researchers published a study in which they considered the incidence among the elderly of various mental health conditions such as dementia, bipolar disorder, obsessive-compulsive disorder, delirium, and Alzheimer's disease. In the U.S., 45% of adults over 65 suffer from one or more of these conditions considered in the study. Calculate the probability that fewer than 320 out of 750 adults over 65 in the study suffer from one or more of these conditions under consideration.
So our proportion is 0.426. So
What formula are you using here, real quick?
well, you have a proportion
Yes.
of
320 over
427.
Mhm.
So shouldn't we be putting that in the probability applet? Dang it. Oh, no, wait, we have, sorry, we need to do p hat minus p. So we got to take our 0.4 to
426 minus the 0.45, right?
right, minus the 0.45.
Negative 0.023, and that's our kind of our T or Z score.
No, we've got to divide it by the sample number.
I didn't see a sample.
750. N is 750.
Negative 0.0003.
Isn't it the oh goodness, the square root of the, hold on, I'm headed to my little notebook here, the portions here. This is 17 here. Okay. So standard deviation.
Stop. I want to tickle.
It's isn't it p hat minus p all over the square root of p times 1 minus p over n? And that gives us our z score.
P, well, because you have to have the standard deviation. Number 3. because the standard deviation is the square root of p times 1 minus p hat over n, which that gives you your standard deviation. And then you take, I was looking at my question here. And my notes are doing me no good at all.
My notes are disappointing me.
You're welcome. Well, we have to take our, well, that's a confidence interval. We're not doing a confidence interval here, are we?
No.
We have to have
Okay,
standard. We've got to have the standard deviation. So
to find the z-score, you don't need to find the standard deviation. You don't need the standard deviation. Well, I guess you can, but you can find the standard deviation without knowing it. So you do p hat minus p all over, and then you do the square root of p times 1 minus p all over n.
Mm-hmm.
And that'll get you the z-score.
So on the bottom of it, I have 0.0182. So p hat minus p divided by that.
I'm still getting there.
dang it, I lost my page.
So for the z-score, I got negative 1.28.
That's what I got. Yep.
Ah, crapazola. Hold on.
That's a new one.
Sorry, guys.
All right, so then area got 0.0, basically 0.1 rounded up.
0.0. Yes. 0.1. Yep.
Yeah.
That's what I'm at. "45 minutes in, we're halfway through the group quiz."
What the heck? Sorry, guys.
You're all right.
I
Read it and then we'll take a break.
am on drugs tonight. Jesus. My head wasn't connected. I would lose it.
See, I know the real reason you're out there in California is you love that sweet, sweet California Kush.
Kush? What do you mean Kush?
You like that they have that medical marijuana out there.
Hey, you're closer to Colorado and they were first.
That's true.
They've got full-on towns there. That's their new industry out there, from what I hear, and it's coming here now. So, what question are we on?
We were on 23. Sean and I got an answer for 23.
Okay, so we were supposed to find. I'm sorry, I lost my papers in that, so they were all over the place. Okay.
And for 23, we got 0.1.
Right, but what was our formula again? That's what I was looking for. I was trying to find the
Okay,
exact,
it was
I
Z
was trying to find the exact.
on top, P hat minus P, and on bottom, it's the square root of P times 1 minus P all over N.
And everything on the bottom is square rooted.
Why
So you have to
doesn't it-
square root that entire function.
You're saying P hat times 1 minus P over N? The
No,
square root?
P hat minus P is on top. Underneath, all of this is going to be under a square root. That's all going to be divided by P times 1 minus P over N.
Right, which is the standard deviation. Okay.
Yeah. So it's P hat minus P divided by the standard deviation.
Right, yeah, it wasn't just the sample.
Luckily, 24 is much easier for us.
Okay, and that one was 0.1.
Yes,
Yeah.
because it came out to 0.0999.
On the
On the applet.
yeah. So 0.01, right?
No, 0.1.
0.1.
Oh,
Because we got
oh, that's right,
0.0996.
Right, because of the rounding. Sorry, my bad. Okay, so suppose you're testing HOP equals 0.62 against HAP is not equal. Calculate the test statistic to be 0 because 1.334. Area to the right is 0.091. Which of the following is the p-value of your hypothesis test? This is one that got us last time.
So just multiply the 0.091 times 2.
Yep. Or if you plug it into the applet, it gives you 0.182.
Yep.
Pick number 3 in the load. All right. Suppose you're a dog breeder. You want to use a confidence interval to estimate the true mean fertility levels of purebred Cocker Spaniels. It is known that the distribution of fertility levels in Cocker Spaniels is normal, of course. How many measurements must you have in order to be sure that the sampling of X is normal? Any N will do.
The first one.
No, because if it's known to be normal, any N will do.
Oh, I didn't see that on my screen. Sorry.
It's okay. I forgive you.
Like I said, a lot of passive aggressiveness in this group meeting tonight. A study is
not passive aggressive.
just aggressive.
I'm just aggressive.
Yep. A study is planned to compare the proportion of men who dislike anchovies with the proportion of women who dislike anchovies. The study seeks to determine if the proportions of men and women who dislike anchovies are different. A sample of 41 men is taken, and the p-hat estimate for the true proportion of men who dislike anchovies was determined to be 0.67. A sample of 56 women was taken, and p-hat was 0.84. Are the requirements satisfied to perform this hypothesis test? Why?
The men one is okay.
I think it's
women.
the fourth one.
Women is not. The woman
Yes,
is
the
not
fourth
greater
one.
than 10. Yeah, what Sean
That's
said, the fourth one.
The last one, because that 56. Oops. 56 times 0.14 is 7, roughly.
Oh, that's where I was screwing it up. I was multiplying the women's value times the men's p-hat. That'll mess you up.
This is why I trust you, Sean or Jared.
A study was conducted to measure the effectiveness of a diet program that claims to help manage weight. Subjects were randomly selected to participate. Before the beginning of the program, each participant was given a score based on his or her fitness level. After 6 months of following the diet, each participant received another score. The study wants to test whether there is a difference between before and after scores. What's the correct alternative hypothesis for this analysis?
I put the third one.
Yeah, that's what I'm thinking.
Yeah.
Cool. 28. Weight Watchers. Blah, 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 blah. One of the clients told that his residual is 5.5 pounds. What does this mean? Residual. So that his actual, the second one, his actual weight loss was 5.5 pounds higher than predicted weight loss.
I'll be honest, I don't know.
Well, if you look at the formula on the residuals, it takes the explanatory or the response variable minus the forecast of everything. So if it's a positive number, that means that it would be going up.
But if they're assuming,
right?
Ooh, so then does that mean that his weight loss was 5.5 pounds lower than what was expected?
This is definitely one of those tricky ones. So as the exercise program as the explanatory variable and pounds lost in 3 months as the response variable. One of the clients was told that his residual was 5.5 pounds. Because see, the response is the pounds lost. So that means that he was losing.
So in this case, higher, weight loss being higher.
His predicted weight loss was 5.5 pounds higher than his actual weight loss.
So
I think because it takes the predicted value, it takes the response minus the predicted.
Well, not for a linear regression. It takes predicted or explanatory minus response.
Not for the residual. The residual is the response variable minus the forecast of everything. It's your y minus y hat. So sometimes it can be very small, the difference. So I'm really.
I think it's either the first or second one, and we'll find out when we turn it in. That's kind of where I'm at right now with this.
Yeah, because we have lots we need to move through. I text my other group and said I'm going to be a few minutes late, so I don't have to bounce just yet.
Okay, I need to charge my computer.
I'm thinking it's number 2, but. Holy cow. We got a lot more to go, don't we?
What's that?
Got a lot more to go, don't we?
Yeah, we do.
Okay, for the study in the previous question, the B1 of the regression line was 5 pounds. Interpret this statistic. That means that is the slope. As percent compliance goes up by 1% on average, 5 pounds are lost.
Was that the slope, or was the other value the slope? I thought that the B was the y-intercept. Nope. Slope.
Yeah.
Okay. Then it would be the third one.
Yeah. All right, so question 30. When creating a scatter plot, a residual plot, and a QQ plot, which questions about linear regression are being checked?
It's not number one, because this is that question we did last time, and I went back and found it, and Susan found it. There is a linear relationship. The variance of the error term is constant, and the residuals are normally distributed. The observations being independent and the X values, you cannot determine either one of those.
Okay. Yeah, this is the one that had us stumped on that.
I remember we checked off
meeting.
4 of them.
Mm-hmm.
Yeah. It wound up being only 3 of them. So pressures of supply and demand. 90 days, 14s. We're going back to direct flight costs.
But I think they want us to do this as independent samples. So it says, because it says in bold, wanted to predict the price of tickets 14 days before a flight based on, oh, just kidding. We are doing it toward samples. Mm-hmm. Yeah, sorry.
Yeah, so it's 14 versus 90 this time.
Oh, so we need to switch those.
Well, and it's, look at the question that it wants. So it wants the sample correlation coefficient. So we need to put that into the t-test for linear regression, right?
Excel just froze, and there we go. We're good. I forgot what it was asking. Sample correlation coefficient on the price of tickets. Sample cost.
And so it wants the 90 days as the X and the 14 days as the Y, right?
Maybe I'm just not understanding what the question is asking, but I'm okay with doing it that way. So 14 days is the X, 90 days is the Y.
Yeah, because it says she recorded the lowest fares for 90 nonstop midweek flights 90 days in advance, and then found the lowest published price for the same, again, 14 days later, or 14 days in advance. So she took which one, the Y's, in response to what the X was.
Okay. Sample correlation. I don't know what the sample correlation coefficient is. I don't know what.
Yeah, that's what.
Well, there's coefficients.
Yeah, that's.
The slope and the y-intercept. No, I'm going to Google what a sample correlation coefficient is.
All right, well, it gives us a, while you do that, we'll move down to 32. It says create a scatter plot using these two variables. We have a scatter plot down there. I think it is.
Well, a scatter plot's got to go horizontal. So that plot that's on there it's a scatter plot. The scatter plot is the residuals, not the data itself.
Well, it gives us this. It gives us a scatter plot down here after we enter these two things in there at the bottom, and so it is linear with a. I think it's the second one on there.
Right, but you've got the. Are you looking at the one graph?
I'm looking at the graph just underneath all that data that we have because that's the scatter plot that it gives us.
Right, that's what I'm saying. That's not a scatter plot. The scatter plot is of the residuals only. This data here is not the residuals. I put one because it confused the heck out of me when we were doing it the other night, and so I went through and went through the textbook and added a graph to the sheet.
Mm-hmm.
And because it gives you your trend line is going to be 0. And so your residuals are either above or below 0. Okay. And but it does show that there is no, it's not megaphone shaped. You know how we were talking about that megaphone thing?
Yeah.
And everything? That's the one that you need to do. So if you take the residuals and add a graph.
Oh, that's right. And we're like having a hard time because we couldn't get it to.
It wasn't
populate.
Everybody's Excel was right. Everybody's Excel was freaking out and everything.
Mm-hmm.
So, but it is linear. It's not showing any distinct pattern. You know, it looks like a hot dog.
With the residuals, and I do a scatter plot.
Yeah, if you highlight the column and then do it, it will always select just the data that's in there.
Yeah, no,
that's why I did honestly, last time I thought.
It looks pretty non-linear.
What do you mean?
Well, maybe I have the wrong chart up, but my chart, it looks like a straight line across.
Yeah, that's what I'm saying, but it's not. It's still kind of random. It's not.
Right.
It doesn't take any shape.
Doesn't when it. Wasn't the thing that like when it doesn't have any sort of shape or anything that it's linear?
Right. Yeah, it is linear because because it doesn't have a definite, like there's no curve.
Yeah.
You know how we did that one QQ plot and it was like had a definite curve in it and everything?
Yeah.
Mm-hmm. All right, okay. Then is it linear with what kind of association with it? Is it?
It would be positive.
Yeah, it's strong. It's strong positive because it's so our correlation coefficient on that is, where is that?
That'd be 0.972 for the slope. Or sorry, that was 0.084 for the coefficient.
Where are you seeing that at, Sean?
I thought it was the R. It's not the R value?
I don't know. I looked it up and I deleted it, but what made sense was that it was the coefficient of the slope. Granted, I could have been reading it wrong.
Here, you know what's cool about the textbook? You just put in what we're looking for, standard, right? Standard coefficient.
Yeah. No, correlation coefficient.
Sample correlation coefficient.
Oops. I know how to spell.
That makes one of us. I don't.
Correlation coefficient. Let's see here. Lesson 22. Regression model. Okay, so regression coefficients. Next, predictions. Y-intercept. Doesn't say anything in that chapter about the correlation coefficient.
We'll come back to that one here in a moment.
Okay.
So that puts us at 33, and it wants to know what our y-intercept is.
For that, I got negative 17.087.
Got something extra. I got 115.640.
Well, I just did it based off of the linear regression. What's it called? The thing in Excel.
Never, yeah, the y-intercept, yeah, should be negative 17.087.
Yeah.
What did I do different then? Huh. All right.
Do you have your data?
You have 14 minus
14.
90, not 90 minus 14.
I have 90 minus 14.
Sorry, 14 is that. So they want
You have
they
90
want
minus
14 days to be yeah, they want 90 days to be y and 14 days to be x.
Why do you say that? Because we
They want
picked
to
our
predict-
flights 90 days in advance, and then it wants a and then hold on. It wants us to predict 14 days, not 90 days. Like, for example, going down to 35, it says predict the price of tickets listed 14 days before a flight based on the same flight costing $200 90 days before a flight. So that question suggests that 90 days is the explanatory and 14 is the response.
And this really messes with my graph. No, it doesn't.
Compute the sample correlation coefficient that placed 14 days before compared with the price of tickets 90 days before. So X is 14, Y is 90, right?
I say X is 90 and Y is 14. Like, look at question 35.
You know, it makes sense that we'd have a positive y-intercept since everything here is positive.
Yeah, like it would make sense because that means the y-intercept would be basically where tickets start at.
Right.
Well, yeah, but you look at like where you're doing the super croc stuff in the textbook, the negative intercept was like the y-intercept was like negative 36.
Yeah.
And all the head lengths were positive.
Well, I feel I could be wrong, but I feel pretty strongly that this is a situation where X is 90 and Y is 14.
$30 is
Like,
so does that mean
she says
33
like
and
in
34 wrong?
so because like it says in capital letters, she wanted to predict the price of tickets 14 days based on the price of tickets 90 days. So you are taking the price of 90 and using that 90 days in advance to predict the 14 days in advance.
Well, yeah. Well, what you're going to do is you're going to use your slope formula.
Yeah, I know that, but I'm saying like because of that right there, we need to set 90 days as the X variable, and Y would be 14 days because of what's in capital letters right there.
Let's try
Right.
that.
So that's what I'm saying. 90 days. 90 days is the X variable, is what you're saying, right?
Yes.
And Y is the 14.
Yes.
Yes.
So does that mean we need to go back and change 33 and 34?
Yes. Also, I think 31 is the R value, 0.780, because that is literally the only thing that stayed the same when I changed 14 and 90.
Yeah, that doesn't change. The correlation coefficient never changes.
Yeah, so it's 0.780.
Yeah, that's why I was saying the R value.
Okay. 32 stays the same. 33 is 115.64.
Yeah, that's what I have.
And the slope is 0.627.
Yes, sir.
Okay, that makes 35. I plugged in 200 for X, and I got 240.979.
Yep. So rounding because only 1 decimal place makes it 241.0.
Oh, that's right. Okay, and we're down to 36.
If I am wrong, I apologize.
It's all right. Lower bound of the confidence interval.
And so on the confidence interval ones for the for linear regression, we use the value that's under slope, right?
Yes, I believe so. So I make lower bound 0.518 and upper bound 0.735.
That's what I got. Yes, sir.
The margin of error would be that minus that divided by 0.108.
Oh, I'm playing catch
yes.
up with you guys. You guys are so much faster than me.
109 is what I have.
627.
I got 0.1082, which I bet you they'll
Okay.
accept both.
Yeah, I think they will too. Because I came with 1.1085.
It's probably, I'm using Excel. I don't know what you're using, but
I'm using a graphing calculator. I trust Excel more.
yeah, mine's going out to like 17 digits. Probably 8,
Mine's
but it feels
giving
like
me 4.
17. All right. For the next 4, conduct a hypothesis test to determine if the slope of the true linear regression line is not equal to 0. So the null is that it is equal and that it's not.
And so slope is B1, so it'd be the second one.
Oh, what question are you guys on?
39.
Test statistic is 11.510.
I have a question
Yes, sir.
Yeah.
real quick. On the confidence interval, you put in the 0.518.
Yes.
Shouldn't it be the 217.188? Oh no, wait, what am I doing here?
I'm not
Wait,
sure
for
where that
which number?
is.
Never mind. Sorry.
Oh,
Talking about for the
no.
confidence
You're
intervals?
You,
That's
you're
why I'm
looking at x
asking.
equals 200.
Yeah, I know that. But okay, so 0.518 and 0.735. That's our
Lower and upper on the slope, yeah.
0.518. Okay, I'm sorry, guys. 0.735. It just seems a little odd to me.
I found those doing the confidence interval for linear regression. It's like I understand where you get the right answer for that part, but I don't know what that necessarily means.
Yeah, that's the point. I don't know what it means. So your margin of error, you took those two numbers and then divided by 2, right?
Yep.
Yeah, one subtract the other and divide by 2.
Okay. What did you come up with? Just so I can catch up here.
0.108.
0.108.
Yeah.
Yes, sir.
Okay. So what are you on? 39 now?
We were on 41, I think.
Holy freaking cow, man! I'm way behind.
You're fine. So these are going much faster than those last ones.
Yeah. Okay. So. Linear regression is not equal to 0.
This one we got the second one because B1 is the slope while B0 is the y-intercept.
The y-intercept.
Right. Right. 40. The test statistic.
And we just took that from the sheet.
The t-value of 11.51, right?
Yep.
Yes.
Which makes the p-value 0.
Okay, 42.
42. I put the third one. We reject the null because the p-value is less than alpha. So there is sufficient evidence.
Yes. It's always like backwards. So when you reject, it means there's sufficient evidence. And when you fail to reject, that means there's insufficient evidence.
Yep. All right, 43. Figuring out which test to do. These are the fun ones coming up.
Oh my gosh. These are the ones where, like, I hate that they give us these questions because we have to basically answer this every time we get a word problem anyway.
Right.
Yeah.
2,800 grams. Go ahead.
Go for it.
Okay.
Study.
CDC carries out a study. The prenatal care program, number of low birth weight babies born for the study, 30 mothers, all in poverty, participate in the program, and birth rate data is recorded. Which hypothesis test would be most appropriate for this study?
This would just be a one sample Z test. Or T test, sorry.
T test, because we don't know the. Well, we have a mean birth weight, but we don't have the standard deviation. We don't know a sigma, so.
Yep. Okay, 44.
Engineers at an oil refinery find out how easily gasoline evaporates by measuring its vapor pressure. As they make gasoline, they need to determine whether its vapor pressure is high enough. The standard deviation of the vapor pressure of the gasoline made by the refinery is always 0.03 pounds per square inch. Which hypothesis test would be most appropriate for this task?
So since we have it, wouldn't it be a Z test? Since we have the standard deviation.
Okay. An attorney wants to know whether the percentage of Walmart employees in Nevada who are over 45 years old is more than 30%. Which procedure would be most appropriate? That would be a test of one proportion.
Yep.
Yes.
Marriage counselor conducted a study of couples, categorizing each couple as communicative or non-communicative Among other things, the counselor wanted to see whether the percentage of communicative couples whose marriage ended in separation or divorce was the same as the percentage of non-communicative couples whose marriage ended in separation or divorce, which hypothesis test. This would
Sets
be,
of two proportions.
yeah.
All right. A business marketing firm specializes in radio advertising. They hope to show there is a linear relationship between sales and the amount of money a client invests in radio advertising. Which procedure would be most appropriate for addressing this question?
That would be linear regression.
All right.
Yep.
I'm going to submit just because I'm not going to be able to have to get to another meeting, and I'll let you guys know what it looks like.
Do you want to let us know which ones we got wrong too?
All right, we missed 6. Let me go through and see which ones they are real quick.
Okay.
Number 5.
Okay.
I put 2.3, by the way, for number 5. It might be 2.5.
Yeah.
I put 2.3.
Number 18.
All right.
Number 21. Number 27.
27.
Number 28.
28.
Number 39.
39.
That's 6.
Did we get 6 wrong, not 5? Can I count? Yeah, simple arithmetic eludes me. We missed 6, and those are the 6 we missed.
Okay. Sounds good. Sean, do you want to go through these 6?
Yeah, let's do it.
All
All right. I'm going to stop the broadcast so I can jump into my other group meeting. I'm sorry, guys.
You're good. Thanks.
Okay.
Hey, good luck on the
Okay,
final.
bye.
You too.
Hey.